Thank you very much, Oleg, for this introduction and for giving me the floor. Dear participants, it's more than a pleasure for me to be with you here in this session and to have an opportunity to present our research directions, results that we have obtained so far, and some future directions. So in my talk, I'm going to cover the following aspects. I would briefly introduce the team involved into this research. I would outline our motivation and goals. I would describe some results achieved so far and conclude future steps. So let's move according to this outline. This work was a collaboration between Ukraine and Italy, in particular Computer Systems, Networks and Cybersecurity Department of National Aerospace University Kharkiv Aviation Institute was involved, together with Software Engineering and Dependable Computing Laboratory of ECCNR, Italy. So actually, these both organizations, department and lab, they work in the field related to safety and cybersecurity issues and have quite strong background and expertise there. So there is no doubt that safety and cybersecurity are very hot topics, and they are not new. They have some history, but during last years, there are some significant changes happened into this field. That's why we have started from a mapping study. The idea was to analyze current state and some future trends regarding safety and cybersecurity assessment. So we have analyzed about 500 primary studies on this topic. And one of the outcomes, one of the key findings here was that there is a strong interest on safety and cybersecurity coengineering. But there was a challenge here that studies mention this possibility, this opportunity, but it's still not mature. That's why we have decided to look more closer. So what is actually meant by coengineering? And our research has shown that typically, or in most cases, cybersecurity is being integrated into safety assessment process. So it's quite common for fields that have quite big history, for example, like aerospace, and safety assessment techniques, like one shown here. This is a well-known fault tree analysis. So we have a top event here, which is safety related. It's ground collision. And we have some safety issues that lead to this event. And also cybersecurity is being integrated into this tree. So actually what we can conclude here, it's not a sort of coengineering in the terms of some joint process, but it's rather an attempt to join two different processes. So, for example, we have cybersecurity analyzed separately, we have safety analyzed, and we can integrate these cybersecurity results into safety. And of course, for critical fields, safety is the most important feature. Another example, which is shown here, there was an attempt to provide a common definition of risk. Yeah, so there is a definition of security risk, there is a definition of safety risk, and combining them together, it was defined so-called industrial risk. But when we look again closer into the methodology described, we can see that it's very similar to one shown in the left part. So we have this attack tree, which is being tied into a safety assessment process. Also, we have looked at normative documents that are relevant in this field for critical industries that are aimed for coengineering issues. And here, situation is not very different. They both different documents, they mentioned that safety and cybersecurity could benefit from coengineering and so on. But again, if we look more detailed on the procedure, it just says, okay, so we have this cybersecurity life cycle, and please do not forget about safety issues during security assessment. Or a similar situation is here. Okay, so when you are analyzing safety, please take into account possible cyber threats that affect safety. One another way that we have found is an attempt to generalize assessment techniques themselves. So, for example, there is a very mature technique, reliability block diagram, which is used to assess reliability. But if we, let's say, focus only on elements that are critical for safety, following absolutely the same steps, but only adding this filter at the beginning, we can get so-called safety block diagram. And all assessments that we receive, they would be related to safety. Or, for example, if we include into this diagram only elements that are potentially vulnerable or can have cyber issues, we can obtain a cybersecurity block diagram, and so on. So this is an idea of generalizing assessment techniques. But again, if we look closer into implementation, it's not so easy. So the process is described and some framework is established, but real use cases here should be used. And also one interesting finding is that not only from a safety side to a cybersecurity side, there is a movement. There is also a vice versa. So, for example, for security field, there is a well-known metric, a CVSS, which stands for Common Vulnerability Scoring System. It was a traditionally cybersecurity metric, but in the latest revision of this metric, there is a supplemental metric called safety. Using this supplemental metric, it's possible to highlight that this vulnerability could be exploited and it could lead to some safety issues. So this confirms that this topic is important, and also there are such possible combinations or such movements not only from safety to security, but also from security to safety. So what is our motivation and goals, considering everything that was presented up to now? So, of course, there are processes of cybersecurity and safety assessment. They are very complicated. They are very resource and time consuming. And of course, there is a clear motivation to reduce efforts required for this assessment. Another motivation is to obtain more precise and trustworthy results. So if we consider more let's say, initial sources that could lead to safety violations, we would obtain more precise results of safety assessment. And as for goal, we would like to develop a unified framework for different domains that would be able to respond requirements which are stronger and stronger year to year. And also, here it's worth to mention that different domains, they have some different maturity in the terms of safety and cybersecurity assessment. So that also should be addressed during such type of researches. So let's move to results that we have so far and discuss them. We have analyzed the terms because that's another challenge. In different normative documents, there are slightly different definitions for safety, cybersecurity, and security. So during these researches, we have used the following terms from, let's say, the most generic or the most, let's say, relevant standards for critical industries. So as for safety, we understand it as a freedom from unacceptable risk. As for security, it's a freedom from unauthorized access. And as for cybersecurity, it's not freedom, but it's rather a set of activities that allows us to protect from cyber threats. And using this terminology and performed an analysis of different critical domains like nuclear, automotive, aerospace, and so on, we have built a landscape of normative documents that cover safety, cybersecurity, or are providing some attempts of coengineering safety and cybersecurity. Which observations can be done from this landscape is that more mature fields like aerospace or nuclear, they have very well established safety normative documents, and cybersecurity is just a new addition. And sometimes it's already integrated into safety assessment process. Sometimes it's just a separate documents, and but some coordination and coengineering is expected in some future publications in this domain. And if you look at more recent domains, like, for example, cyber physical vehicles or smart grids, there cybersecurity is a topical issue, and there are some let's say, more detailed procedures and normative documents of cybersecurity assessment. And that actually could be easily explained, yes, because all these new systems, they are secure by design. And we can't say the same for some more mature domains, yes, because their main idea at the beginning was to operate correctly, and after that, operate safely. But cybersecurity was introduced a little bit later. So we have looked into several domains more precisely. And for example, in a nuclear domain, there are two documents that address cybersecurity and safety. One of them is from International Electrotechnical Commission and another from International Atomic Agency. But again, we can conclude that they just state that security should be addressed during safety analysis, and that's it. Therefore, in our work, we have analyzed cybersecurity and safety life cycles, and we have a specified set of actions of safety and cybersecurity coengineering actions that could be done or implemented during this life cycle stages. As for automotive domain, we have analyzed the well-known standard on functional safety. It's ISO 26262, and a relevant document on cybersecurity for automotive field. The problem here is that these two documents, they do not have bridges between them. So if we use them one by one, it's absolutely okay, but it requires a lot of efforts and so on. So we have tried to build such kind of bridge and combine safety lifecycle defined in ISO 26262 and cybersecurity lifecycle. And this is our attempt of integration and alignment of these two domains. So, for example, the first stage, it's not only a safety risk assessment or cybersecurity risk assessment, it's a cross-domain risk assessment. And the same for the next one. Yes, it's a unified risk management. So now we are not focusing only on risks associated only with cybersecurity, but rather those that are related to cybersecurity and to safety. As for railway domain, we have focused here on artifacts produced during life cycle stages, safety artifacts and cybersecurity artifacts, and also tried to harmonize them and to see which or production of which artifacts could be simplified by using this coengineering process. And actually, in railway domain and in automotive domain, normative documents, they are quite well described. Yes, so the only challenge now is to integrate different domains together. And this work has not been done yet, and it still requires further investigation and moving forward into this direction. So if we conclude from what was presented, we would like to mention that yes, safety and cybersecurity co-engineering process is not novel one, but it's still not mature. Saying that, what we mean, it's there is a promising direction of research here. Because all these concepts, they are absolutely different in different domains. Some aspects are better worked in nuclear domain. Some aspects are much better in cyber physical vehicles, for example. And if we utilize the top results obtained in these different critical fields, we can at least propose a unified approach that would benefit from all these aspects. And of course, there is a clear need in this field of methodological support, because as of now, domains are not interconnected properly. And as for overall recommendations that could be done from this research, they are the following. The first one is artifact traceability, meaning that artifacts produced during safety assessment or cybersecurity assessment, they should be traceable so as to simplify identification of their possible bridges and interconnections. Cross-sector collaboration is extremely important here, and that's one of the main promising directions. So, as I just said earlier, we should take the best achievements from nuclear, from automotive, from aerospace, from cyber, physical vehicles, smart grids, and so on during development of this unified framework. Another important aspect is incident response and recovery, and documentation and reporting. Again, in different domains, this situation is absolutely different. For example, in oil and gas, there is a quite well-established incident response system where we can identify attacks that were performed against some oil and gas industries, and using that database, we can, let's say, use the best practices so as to protect from such cyber threats. But in other domains, it's usually not the case, and it's a very difficult question because some companies are not ready to, let's say, disclose or make publicly available such type of quite sensitive information. And of course, training and awareness should be done here in this field so as to motivate efforts into safety and cybersecurity coengineering. So thank you very much for your attention, and let's move together to a safe and secure world. And I would be happy to answer your questions if you have any, and I would be very thankful for any comments that you make now. So thank you.
Thank you again for this presentation of possible combination of safety and cybersecurity in different domains. So I see the hand from Irina, which was raised from the beginning of the presentation. So Irina, please, do you have any questions?
Yes, I do. And again, thank you very much for your presentation. All right. I'm not sure how far you are in your research and when you're based, or you're based in Kharkiv, or correct? And Italy, is it correct also?
Both, yeah.
Both. All right, okay. So in this case, I can comment a lot. So first of all, risk assessment indeed is an essential part of every big business or critical infrastructure businesses. By law and by certain procedures, by certain regulations, we need to do the risk assessment or cyber risk assessments minimum 1 time per year. Moreover, for the businesses exists the right of the license operate. It means that for certain activities of the companies, when companies making the money, they must comply, or they must have a standard and comply with the certain standards of the industry in order to operate on this market. So these standards includes certain type of the risk assessment or cybersecurity assessments, for sure. Sometimes it's even like twice per year. It depends on the standards, and it depends on that particular business type and domain we are talking about. So it's already there. Moreover, certain standards already includes the procedure and the methodologies kind of guide the companies who is the auditors, and many Ukrainian auditors are super successful in Europe. By the way, in Italy, you have one of the most successful and biggest company who is the auditor in cybersecurity. And the Europe is really having a lot of good professionals, and those people are using those methodologies that is and the risk assessment or the cyber assessment has already predefined methods that includes in these methodologies. I will not go into details. However, this is in my knowledge because I am doing that in my daily work. And the second, the second and the third after. So there are a lot of regulations and normatives that belongs to the critical infrastructure or structural companies, as we call it in Europe. It calls, for instance, the updates from NIS, it's NIS2, that is particularly for the critical infrastructure. We have European Cyber Resilient Act that just was, it's a kind of regulation that's similar to GDPR. However, it also includes guidelines. It also DORA, that was particularly established not only for financial markets, but also for the banking and pharmaceutical industries they need to comply with. And that requires and also defines certain way of conducting penetration tests, reporting, exercises, trainings, etc., etc. I can name it because I have a list in it. I'm working with that. So this is also important to say. What are not, and you're right, it's not a mapping between those methodologies or those regulations and requirements and the company's way of working, I would say like this right now. However, companies, especially companies in those fields that you just mentioned, which is very highly critical for any region, any country, like energy-related field or pharmaceutical or manufacturing, or even other fields that the defense field, they are not mapping yet, certainly, their processes against existing regulations because, in my opinion, it's just lack of the resources, time, and it's just very, very fresh standard that we have. So this is already, it's certainly not, but this is what I honestly didn't find in the research, is also mentioning those standards and those regulations and the requirements that our companies needs to implement in order to be able to be able to maintain their business. And that should be, in my opinion, also mentioned. Maybe it is in your research. I don't know about that. So my question was, this is comments, all right? So my question, honestly, what you mean by coengineering? This is, I really, honestly, not aware about that in terms of that. I don't feel I don't have solid knowledge what it means, coengineering. Maybe you will share your opinion. I would appreciate that. And well, the segments you already mentioned, but maybe you will also say just in general what other segments or domains you research for. So who is your target audience? And I think that's it. And thank you very much again. Once again, in Italy, by the way, in Italy, you have a very strong, and Spain and Italy have a very strong space defense agency, who is for its European Union body, like a part of the European Commission. As you know, they're very strong, they're very knowledgeable. I encourage you all to look at them. They are publishing fantastic researches. If you have any questions, you can contact me. I will give you more details. And I am very curious at the end, how can I get your slides? Because I do like your presentation. And that's it from my side.
Thank you very much. Thank you very much for such comments and really appreciate your feedback. It's very important for us to hear what is the impression of our research. And as for domains, we are mainly focused on critical domains where we have some practical expertise. In particular, in nuclear domain, we have a strong collaboration with industrial partners, and we have participated in different licensing processes. And as you have mentioned, yes, it really requires a lot of involvement of different auditors, and the processes are quite formalized. And actually, it's not a trivial task. And as for coengineering, what do we mean by this term in safety and cybersecurity coengineering? This is just a unified framework during which we are addressing safety and cybersecurity together during all life cycle stages of product design for such critical industries. So, for example, starting from requirements and ending with some putting system out of order. Because as of now, there is no such framework in different industries, and there are quite strict requirements to build a safe system. Of course, in modern world, it's not possible without taking into account cybersecurity issues. So by coengineering, we mean addressing safety and cybersecurity at once during the unified process at almost absolutely all life cycle stages. So that's from my side.
I can add from my side as well that the definition of coengineering is actually the combination of two words, cooperative engineering. So, and actually our goal is to achieve the, let's say, big safety and security assurance of the particular instrumentation control system in different domains. And particularly, we were engaged in the verification and validation of several domains, and plus we have some, let's say, practical experience in energy sector, in nuclear sector, and partially we cooperated with the guys who are working with the certification of automotive domain and railway domain as well. So yeah, for sure, we'll share the slides. Thanks, maybe we'll have some mutual cooperation in future. Okay, thank you very much for the questions. Thank you, Evgen. And okay, so we are moving towards the next presentation.